Hi everyone, in today's video we'll actually start generating vectors. Our first technique is going to be bag of words, and you don't have to create your own model for bag of words because most of the packages in Python already have like Skylearn, and we're going to use that. But we have to understand what it's behind the model and what are the calculations that the model does and what is the basis for this bag of words model and how it creates the vectors that we're going to use later on. So first we will go over some slides to get the theory, and later we will generate some code in Python. Here we have the content for this week's video. We will have the introduction, word frequency, vectors, examples, sparse vectors, the framework, and you have some references if you want to go deeper in what is bag of words and how to use bag of words. Bag of words is known to be the simple method to generate vectors. It works on phrases, paragraphs, or documents. We can make a vector word by word. So we're going to have a dimension by the size of the number of words in that document. Or we can have a word phrase that we're going to have the dimension of the vector as the number of phrases in that document. Or we can have paragraphs or documents. It describes the frequency of words within a corpus. That's the only thing we generate with bag of words. It's basically a vector that says how many times that word appeared in that text. So we can see here this image that says that we have an object and we transform this object in a bag of words. That means that we're going to take out every component of the object and put in a bag and shake it out. We don't care if the eyes are in this specific part of our face. In fact, when we put them all in the bag, we lose that contest. So that's one thing to keep in mind when using bag of words. We don't know the position of the word or the context of the word. So what is important for bag of words is the word frequency. Here we have a text in our left side that we can see that very is the first word, and also we have in the last sentence very, very, very good movie. When we get this document, this corpus, and we put in the bag, we don't care in which position the word appeared. We only care how many times that word appeared. So we're going to count every time the word appeared in the text and put it as a frequency. So we can see the result in the right side where we have the 8 times, comma 5 times, very 4 times, and so on and so forth. So in the end, what we have is a list of words, our vocabulary, and the frequency of the words. So how many times that word appear in our context. As we already said, bag of words does not consider grammar or word order. It only keeps track of the word counts, and as our vocabulary size increases, the vector size will also increase. And the memory for storing that embedding will also increase. So we're going to need more memory to store those vectors. That's the problem with bag of words. We're going to generate a very huge dimensional vector, like with a lot of dimensions. Here we have a phrase, the dog is on the table, and the phrase vector is 001101112. And that's because our cat and now are not present in the phrase that we are analyzing, but they are probably present in the document. They are already there. And we are analyzing just one word of the document. And we can see that the appears 2 times, and we have this value 2 for the word the. And remind again that this is a phrase vector, not a word vector. To understand those different types of vector, like phrase vector, document vector, we will go over an example. As a pet, cat is very useful animal. kitten is a smaller and cuter version of a cat. Cats are found all over the world. There is no place without a cat. We know that the vocabulary size of this text is 25. So we have 25 unique words in this text. And we generate the vectors for the paragraphs. We know that we have two paragraphs in this document. And we generate two vectors for the paragraphs. Paragraph 1 has one vector and paragraph 2 has another vector. So we can see here that the paragraph 1 vector have 25 dimensions because that is the size of the number of the words that we have in the document. And at the same time, we can see that the word cat vector is 2 and 1. And that is because we separate the document in two dimensions, paragraph 1 and paragraph 2. So we have two paragraphs and we can see that the number for the vector cat is related to the number of times that that word appears in the paragraph 1 and paragraph 2. Let's say cat appears in the paragraph 1 two times and one time in paragraph 2. So that's why we have the word cat as a vector is represented by 2 and 1 when we consider the separating the text in two paragraphs. Now we have the exactly same phrase, but instead of separating the document in two paragraphs, we're going to separate in four phrases. So we have here the phrase vector is again a vector of dimension 25 because we have 25 words. And the word cat vector will have 4 dimensions because we have 4 phrases in this document. 1, 1, 0, 1 is the vector cat for this example where we consider the phrases. So we have to keep in mind if we're going to separate in paragraphs, phrases, or words our text. For bag of words, this is extremely important. Now we consider the exactly same example, but instead of splitting our corpus into phrases or paragraphs, we're going to split into words. In the end, we're going to have a vector of dimension 25 for each word, and that's because we have 25 words in our vocabulary. We can see in this example, the word cat has all the entries equals to 0 except the one where cat is in the row and cat is in the column. And that's because we are considering words and different than phrases. Every time the word appears in the phrases, we're going to put an entry. In this example, we will only put an entry when the word appears in that word. So that's why we don't like when using bag of words generate vectors word to word because we're going to have a lot of dimensions, in this case 25, and all the other entries will be 0. So we'll only have one entry with a value, and now the other dimensions will be equal to 0. That's something that we have to keep in mind when using bag of words. Sparse vectors. So we have to keep in mind that if we generate a bag of words vector for an entire book, the length of the vector of each word or each phrase or each paragraph will be thousands or millions of positions because the length of the vector will be equal to the size of the vocabulary, and in a book the vocabulary will be large. This will result in a vector with a lot of zero scores. We call this a sparse vector. We can see here that a vector that it's called a sparse vector will have more zero entries than non-zero entries. We have a very simple framework for bag of words. First, we have to do the text processing, and like I said before, we have to generate this clean text before we create a vector representation of the words. We're going to tokenize the clean text. If it's not inside the text processing, it must be done right after. We're going to create a vocabulary, frequency count, and generate the vector representation. Those last three steps are the bag of words model. It's very simple to to create a bag of words model from scratch, but we don't need to do because many packages in Python have that already built in. But if you want, it's just simple. You have to create your vocabulary, count the frequency of words, and generate a vector representation based on what you want. If you want the parameter to be a phrase or a document or even the words, you have to take this in consideration when you are creating your vector representation. That's all we have for bag of words. It's very simple and very intuitive because we know what frequencies are. So if you want to see what they are doing out there with bag of words, please check our references. And if you have any questions, let us know. Bye bye, see you next time.